Hello, I'm Bo Weidema. This is the 8th video in a series of 10 on consequential modeling in lifecycle inventory analysis. The topic of this video is how to identify the determining products in a situation of co-production. The definition of a determining product is that it's a product of an activity for which a change in demand will affect the production volume of the activity. This is an eco-invent terminology called a reference product. In combined production, you have the situation where co-products can be varied independently. That means that all products are determining, and the unit process can be subdivided according to physical causalities. An example of this is petroleum refinery, where the main products, jet fuel, diesel, petroleum, or petrol, can be produced in varying quantities depending on the demand on the market. In joint production, the amount of co-products cannot be varied independently. That is, their proportions are fixed. The determining products must therefore be identified by analyzing the existence of alternative production routes, and that is what I will explain in the following slides. An example of a joint production is soy oil and meal, where the proportion between the two products are given by a biological basis. With milk and meat, you can ask the same question: is it combined or joint? Because milk and meat outputs may be varied within some possible ranges depending on how you're feeding your animals and so on, then one could argue that it is a combined production. However, the production of milk is typically what you're optimizing the production for. So when you're optimizing the production for one output, you cannot really vary that output anymore, so it becomes a determining product. In the procedure for describing determining and dependent products, we start with excluding those outputs which are just wastes and provide no revenue to the activity. So we focus on the products alone, and then we look at situations of combined production where the co-products can be varied independently, and those we have already talked about being treated by physical modeling of the individual products. So that leaves us with joint production, where we have three different kinds of situations. Type 1 situation is where we have one joint product without alternative production routes. In that case, this is the determining product. We can also have a situation where all the joint products have alternative production routes. Still, only one of these co-products is determining. And we need to analyze data on marginal production costs and revenues and normalized market trends to identify which of the outputs are the determining one. This we call the type 2 situation. In the type 3 situation, we have more than one joint product that has no alternative production route. In that case, all of these will be determining products. Together, type 1, 2, and 3 cover all possible situations. In the type 1 situation, where we have only one joint product without alternative production routes, then this product is typically the determining one. simply because it's the only way to produce that product. We can take the dairy cow as an example, where the only way to produce cow's milk is really a dairy cow. When we say typically, that is because that product must also alone provide sufficient revenue to change the production volume. If it doesn't provide sufficient revenue, then we will still have to look at the other co-products. Now, the type 2 situation, where all joint products have alternative production routes. The key to solve this problem is that the determining product is always the limiting factor for changing the production. And to identify that limiting factor, we apply a 3-step procedure. The first step of that procedure is to exclude those joint products that provide so little revenue that they cannot contribute to the ability of a combination of the joint products to exceed 80% of the total revenue. Now, these 80% is a default threshold that reflects the net marginal cost of changing the production volume. Since typically the total production volumes revenue will have a cost of production that is at least 80% of the total revenue, then this threshold is given as a default. But in practical situations where you have better information, you can of course apply a different threshold. Now, let's take an example to illustrate this. A soy oil mill and refinery will produce soybean oil, soybean meal, and free fatty acids. So to identify which of these 3 products is the determining one, we first look at the revenues from the 3 products. Soybean oils per kilogram produced, we have 4.1 kilogram of soybean meal and 120 grams of free fatty acids. The revenue provided from these 3 products is respectively 42%, 57%, and 1%. So you can see that in order to reach 80% of the total revenue, so to be able to change the production volume, you need at least to combine the soybean oil and the soybean meal. But the free fatty acids, it doesn't really matter whether that is 1% or larger. It would have to be significantly larger revenue from that before it could influence the ability of the combination. So we can simply exclude that by this 20%, 80% rule. Next step is to look at the market trends of the non-excluded products. Here we have only 2 non-excluded products left, and we normalize this market trend to the product output from the activity. First, let's look at the general market trends. The vegetable oil market has an increase annually of 6.4 million tons, here expressed as teragrams. The protein feed market globally has an annual increase of 3.5 teragrams. Now, taking these 2 market trends and normalizing them to the outputs of the soybean meal, that means dividing by the 1 kilogram for the soybean and the 4.1 kilogram for the soybean meal, then you have the normalized trends of 6.4 and 0.85. Clearly, the soybean oil has the highest normalized trend. We are using that in the 3rd step of the procedure, namely that of starting with the joint product with the largest normalized trend in this case the soybean oil, and looking at, does this have enough revenue in itself? Well, we already talked about that it did not. So that cannot be determining in itself. Then we add the next largest trend product. And of course, here there is only one to choose from. But if you had 5, you could imagine a situation where you only needed 3 of them to get above the 80% revenue. And then you would stop the procedure at that point in time. Here, we're just noticing from the soy oil mill that the soybean meal is the last added product, and thereby increasing the revenue to above 80%. And we can say the meal is necessary, but it's also limiting the amount of soybean oil that you would meaningfully be able to produce economically, because the demand for the soybean meal is what limits the total production. And what is important to notice when we're talking about these normalized market trends is that the market volumes are for the generic markets. So not soybean oil market, but vegetable oil market generically, not soybean meal market, but protein feed market generically. Because the soybean oil and the soybean meal, of course, are joint products and therefore produced in exactly these fixed quantities. So their trends will always be the same. It's only when you look at this larger market that they feed into that you can talk about the market trends, the normalized market trends being of different size. The type 3 situation, where more than one joint product have no alternative production route. This is something that happens very seldom in practice. But since it can happen, we need to deal with this as well and find out how to handle that situation. The case example is a slaughterhouse. Here, a slaughterhouse for beef. A slaughterhouse have cattle live weight as input, and as output it has cuts of meat, and the rest is minced meat. Then of course you also have some hides and bones, intestines and blood products that we all could say we know how to deal with these, because these are typical byproducts that have other uses, all other alternative production routes. Like hides go for leather, which has alternatives in form of leather substitutes. Bones provide protein, intestines as well. Blood is also a protein product, and so on. There is alternatives for all of these at the margin. Now, we're left with the cuts and the minced meat and have to say, well, actually both of these, there are no other way to get minced beef than from beef cattle. There is no way of getting a cut of beef meat than from beef cattle. So we need to find a procedure to deal with that. What will actually happen in reality when we have a consumer that is asking for, let's say, 1 kilogram of minced meat at a price of 86 Danish kroners per kilogram? The slaughterhouse don't really care about how much it sells of the different cuts or minced meat. What it cares about is how much money is the consumer willing to pay for this. And since the consumer only pays 86 Danish kroners, the reaction of the slaughterhouse is to produce total outputs of the determining products at a value of 86 Danish kroners. But since the cuts are so much more valuable, then the total amount of outputs of determining products that are of 86 Danish kroners, out of those, the mincemeat is actually only 7 Danish kroners. So we only get 82 grams of minced meat from this additional demand. the rest are cuts that we didn't demand. So where does the rest of the minced meat to the consumer come from? Well, it comes from other consumers that reduce their demand and liberate that minced meat to the consumer that wants to pay for it. Of course, this can only happen through a change in price. When the consumer asks for more minced meat, then to have more minced meat given up by other consumers, there needs to be a price adjustment. Now, the hides and bones, intestines and blood, of course, are also changing, also increasing when you have this additional demand for minced meat. But for those, we know the procedure, how to deal with that. So we don't talk about that here. What we care about is what will happen with the additional cuts that come from these additional demand for minced meat. Nobody asked for these cuts. So how do we deal with that? Well, in practice, there is only one way of dealing with that, and that is lowering the price of the cuts until other consumers will demand them. And in the end, the consumers that give up their minced meat and the consumers that increase their demand for cuts equal out. Both of those will have a value of 79 Danish kroners, and the amounts you can see here. 456 grams of cuts are increased consumption and a decreased consumption of 980 grams. Now the whole system balances both in terms of money and kilograms. Now, of course, you can question, will this happen in practice? Will it be the same consumers that give up minced meat and buy cuts instead because of the price difference? It could also be different consumers. And in fact, some people would question, well, wouldn't what happen would be that there are situations where minced meat from beef can be substituted by minced meat from, for example, pork, so that we don't have a situation of more than one joint product, and we could go back and use the other procedures. That may well be the case, but then you would need empirical evidence for this happening. So we need to study the markets and seeing what actually happens to the prices when the demand for minced meat goes up or the demand for cuts go up, and then we simply model that until the whole system balances again. That is what the economists call clearing the markets. Now, with these three procedures, these three situations of dealing with co-products, we have identified the determining product in all these situations, and this is an exhaustive treatment. There are no other possible ways than these three types of situations. So you should be able to identify the determining product in any situation you may encounter in real life.